Hello, and welcome to TrainSignal. I'm Don Jones, and this is the Backup and Recovery lesson for the Database Administration Fundamentals course. In this lesson, we'll talk about the basics of SQL Server backup and recovery, including database recovery models, how to make a database backup, how to make a transaction log backup, a little bit about backup devices, and we'll cover the database restoration process. Remember that in a previous lesson, you learned how SQL Server modifies data and how the transaction log works within that modification process. The log is very important to the entire backup and restore infrastructure, so make sure you review that lesson if needed. Each database in SQL Server is configured to use a specific recovery model, and there are 3 to choose from. In simple recovery mode, transaction logs are truncated automatically on a regular basis, limiting your recovery options but lowering your maintenance overhead. It is crucial to make sure you get a regular full backup of your entire database because you will not have the transaction log available to recover from. Full recovery mode is the most commonly used in production environments because it lets you restore to any given point in time, since transaction log entries are time-stamped. You must, however, manually shrink and truncate your transaction logs or they will grow forever, taking up an ever-increasing amount of disk space on your server. The last recovery model is bulk logged. It sits somewhere in between the first 2. You can't use it to do point-in-time recovery, but it does utilize less log space. It is the least used model. Frequently, a database administrator might put a database into bulk logged mode during a large data loading operation and then switch it to the more commonly used full recovery mode later. Let's quickly hop into SQL Server Management Studio and see where to set the recovery model for a database. Setting the recovery model is done as part of a database's properties. So select a database, right-click, Properties. You'll find this on the Options page, and it's here, Recovery Model. Let's just go ahead and change this one to the Full Recovery Model and click OK. And that's all you need to do. Of course, it's important to make sure that you've got the right amount of space available for a transaction log if you're using anything but the simple recovery model, but aside from that consideration, it's a pretty easy change to make. There are a few different types of backups in the world. A full backup consists of everything. Now in SQL Server, this can also be limited to just a specific set of files, called a file group, if the database is spread across multiple files. Or you can back up the entire database, which will get all of its data. A differential backup consists of just what's been changed since the last full backup, regardless of any intervening differentials. So if you took a full backup on Monday, and then on Tuesday, Wednesday, Thursday, and Friday you took a differential, Fridays would be the largest of the differentials and would include whatever had changed on Tuesday, Wednesday, and Thursday. An incremental backup is similar, except that it only grabs what's changed since the last full or incremental backup, whichever was most recent. So your incremental backups on Tuesday, Wednesday, Thursday, and Friday might each be roughly the same size. They would not overlap one another. You would need all of them in order to fully restore the database. Finally, a log backup restores just the transaction log. These are very short and very quick to perform and help ensure that the active transaction log is backed up. Once it's backed up, the active log can then be truncated. Transaction logs do need to be truncated periodically. This is done automatically with the simple recovery model. Truncating removes all checkpointed transactions, meaning all of those transactions that have been successfully committed by SQL Server to the database file on disk. You should only truncate after backing up the database file, thus ensuring that you have that data safe someplace else, so that if there's a disk failure on your server, you have that backup to rely on to recover that data. Let's get into SQL Server Management Studio and see how to take a backup and where log truncation is configured. Backups are fairly easy to perform through SQL Server Management Studio. Right-click your database, select Tasks, and then select Backup. You'll indicate the database you want to back up, the type of backup you want to make, either a full, deferential, or transaction log, what you want to back up, let's just grab the entire database, where you'd like that to go, and then you have to add a destination. Because I don't have a local tape drive connected to my computer, I have to back up to a disk file. You can add as many of these disk backup devices as you like. On the Options tab, you can specify a number of different options. I can append this backup to whatever's already in that disk file, meaning each file can actually contain multiple backups. I can verify the backup to make sure that the data went in correctly. I can perform a checksum before writing to the media to make sure that the media isn't corrupt, and so forth. If you're performing a transaction log backup, then on the Options tab, one of your options will be to truncate the transaction log. And that allows you to clear the log out and make room for new incoming transactions. That's something you will need to do periodically to make sure that the transaction log stays cleaned up. So let's go ahead and on the General tab, switch back to making a full backup. We will just click OK to let that happen. You can see it executing down here with the little spinning green wheel. And we're done. Now let's go in again and take a transaction log backup, just so we've got everything safe to disk, and we'll go ahead and truncate the log. You can see how quickly those transaction log backups run. It's like nothing even happened, but you can check the little status there and see that it works. So now we've got a good backup of both our database and our transaction log. The transaction log has also been truncated, meaning all checkpointed transactions, which are now backed up, are safe on disk and the log is cleared out so that there's room for more incoming transactions to be written. Now I mentioned file groups. Keep in mind that databases can be spread across multiple files. When you create tables, views, and so forth, you determine which file they're physically stored in. So you could, in theory, modularize a large database by keeping closely related items in the same file. You could also group those files together into file groups, which is just a named set of files. A partial backup gets all data in the primary file group, every read-write file group, and optionally, if you tell it to, any read-only file or file group. A differential partial backup contains only the data modified in that same set of files since the last partial backup. Partial backups are designed to make backing up a humongous database a little bit easier by letting you break up the backup process into different discrete phases. You can also use a file backup to back up individual files, and both full and differentials are options then. Note that in modern environments, it's typically not usual to see the partial or file backup approach. Organizations these days, especially those with humongous databases, tend to store them on a storage area network, or SAN. And that tends to more or less negate any of the performance benefit of having multiple files because the SAN itself takes care of spreading the database out across many different physical disk devices. In fact, these storage area networks often enable more advanced backup methodologies, removing or at least bypassing SQL Server's native backup capabilities as a need. And to be honest with you, serious database administrators rely on serious backup solutions. They rarely rely on the native capabilities in SQL Server. It's important that you understand what SQL Server's native capabilities are, but be aware that most production environments do not rely heavily upon them. Now, a backup device, as you saw in a previous demonstration, can either be a file or a tape. You can append new backups to a device or overwrite existing backups within a device. A device is essentially just a destination for backups. In the example you saw, it was just a file sitting on disk. That file can actually contain multiple different backups. It might contain 2 or 3 recent full backups, some log backups, maybe even some differentials. It's just a convenient container for keeping the backups in. SQL Server's native backup capabilities are able to run backups with minimal impact to ongoing production work, so it's not impossible to run your backups even in the middle of the day on a busy day. Now, a full backup of a large database might be impractical just because of the performance impact, but for smaller databases or for incremental or log backups, performing those in the middle of the day is not all of that unusual. Now again, large organizations with serious production databases do not tend to rely on SQL Server's native backup capabilities. They're more likely to have third-party backup tools that are much more robust and offer a lot more options and flexibility. Hopefully you'll never have to restore data, but if you do, here's the process. You'll typically start with the most recent full backup of your data. You then apply the most recent differential, or if you've been taking incremental backups, you apply all incrementals since that last full backup. You then apply the transaction log backups that have been made since the most recent differential, incremental, or full, up to your desired recovery point in time. Then you tell SQL Server that you're done restoring backups, and you let it start replaying those transaction logs to bring the database up to date. There are some options for less than full database recovery, such as recovering just a single file or file group. You can actually restore individual pages within a file, which can be useful if you've had some disk-level corruption and lost a particular page. And you can also do what's called piecemeal restore, which is where you start with the primary file group and then move to secondary file groups. Let's hop into SQL Server Management Studio and take a look at some of the options for restoring data. Management Studio also makes restore operations pretty easy, especially because restores can get so complicated. Right-click the database you plan to restore, go to Tasks, and then Restore. We'll restore an entire database. You do not have to restore the data to the database it came from. For example, if you need to maybe copy some data from a restore, but you don't want to completely overwrite the existing database, you might take the backup to another database, and that way you've essentially got two copies running at the same time so that you can move data between them. You can recover to a particular point in time, or to the most recent state possible based on the backups that you have available. We are going to restore both our full database backup and our transaction log backup. Now that should get us pretty up to date. The only data that we'll be losing is any transactions that have occurred since our transaction log backup was made. We've got some options. We can choose to completely overwrite the existing database, preserve replication settings, prompt before restoring each backup in the series, and so forth. The recovery state is probably the most important set of options, so let's review those. The default is to leave the database ready to use. We're going to roll back any uncommitted transactions, and once we're finished, we do not have the ability to restore additional transaction logs. The next option would be to leave the database non-operational. Do not roll back uncommitted transactions, and provide the ability to restore additional transaction logs if we've got more of them. We can continue restoring transaction logs as necessary to bring the database as up-to-date as possible. Our third option is to leave the database in read-only mode. We do want to undo uncommitted transactions, but save those undo actions in a standby file so that the effects of our recovery could be reversed if desired. We'll go ahead and take the first option there. This will take a little bit of time to execute. We can watch the little green wheel spin while it happens. Restored failed. And this is fairly common, and it's one of the things I wanted to make sure I showed you, so I'm glad it happened. It's saying that it failed because it could not get exclusive access to the database because the database is in use. Likely we've got other users who are in here messing with the thing, and, well, you can't restore a database if someone is in the middle of using it. That's why it's actually not that uncommon to restore to a separate database. We've got a number of different things we could do. For example, we could take the database offline. We could make it read-only. We could take the entire server offline if we wanted to so that no one could connect to it, although doing so would also affect all of the other databases on the server. The point is that in order for SQL Server to do a restore, you do need exclusive access to the database. This lesson provided a brief tour of SQL Server's native backup and recovery capabilities. We talked about database recovery models, and how to make both database backups and transaction log backups. We talked briefly about backup devices and covered the basics for the restoration process.